hope inshallah. طيب, in dynamic memory management, so the operating system manage the memory dynamically. Dynamically, it means there are always changing coming. It depends on the situation. If you have many processes, less processes, few processes, etc. So processes, small processes, large processes, so it change frequently. So it has to respond frequently. So this is the sense of dynamic. So the operating system manage the memory dynamically. So this is a simple example. At the left side here, this example we explained last class, so I will explain it again here, and we take a practical, more detailed example about it. We have three processes occupied in memory. We have process 5, process 8, and process 2. And suppose the whole memory is full. The gray area here, the gray area is representing that we have the memory full memory. These three processes are taking full memory from the RAM, and the operating system is running here in this blue area. Now suppose process 8 ended, terminated. So what will happen? We will imagine the other here, this hole, this white area, okay, with the blue borders here. So once process 8 terminated, so the uh, memory area is free. So this free area, we call it hole. Okay, so we have got a hole, a free memory area available for any new process that might come. So the remaining processes, process 5 remain in the same area in memory, and process 2 remain in the same memory area, and we have in between here, we have a free memory location. Now suppose in the next here, in this next, suppose we have a process 9, process 9 came new for now ready for execution, and it need memory allocation, need memory space, but it is smaller than the whole, smaller than the whole. So we put it here in this area, and the operating system put it here, okay, and the whole gets smaller. And then suppose we have another process, new process like process 10, and also smaller than the others, and we have enough uh, free area for it, so we placed it here in this area. So the hole is getting smaller and smaller. So the hole was big here, now it gets smaller here, and this is the smallest hole available. So this small hole here, this is a waste. This is wasted so far, and here this is a waste, and here is this is a waste. So if we can put more processes, this is better to utilize the memory. Okay, that if we have more processes, but and if we don't have enough memory for the processes, then the process have to wait. So this is the simple mechanism of memories and holes. So I will give you now an example, okay, about how to calculate the memory location, and how to allocate the memory, and how the operating system might behave in allocation of memory. So the whole is a block of available free memory. Okay, it has various sizes, so, and it is scattered throughout memory. Scattered يعني distributed all over the memory, يعني anywhere in the memory. So the operating system maintain information about the allocated partition and the free partition. So any area in memory that, like process 5 here, it will start from this point and it will end to this point. We call this an allocated partition. Allocated partition. And here the whole, we call it a free partition. Right? Now the operating system might in order to allocate these processes in memory, to put them in memory, and he must decide to which hole the operating system must put the new process. For example, we have here a large hole, and here we have a medium hole, and here we have small hole. Now suppose we have a process that can fit in any of those. Yani it is small enough to put it here or here or here. We can put it anywhere. We have three holes. Now the operating system need to decide in which hole he will allocate the this small process. So this is a kind of يعني, a decision need to be taken, and there should be a strategy for this. So and I will show just a little example here now, just to get the idea better. So there are basically three strategies the operating system might use to allocate a new process. So for example, I have a process here, and this process number, whatever, process 11, okay, and this is a small process, and it needs small memory. So it can fit here. This is the operating system can put it in this big hole. Also, he can put it in this small hole. Also, he can put it in the medium hole, medium size hole. So which one to decide? So we have three strategies. The first strategy is first fit. First fit. So what does first fit mean? It means simply we have to, or we have the holes in order. We order the holes, hole number 1, hole number 2, and hole number 3. Okay, we have the holes in order. And once we have a new process, first fit means we put the process in the first free memory in order. So we have this one, number 1 is free, we put it here. Okay. Suppose we have another one, process 12. Okay. Also it is small. So we want to put it in the first fit. Also the first fit. Where is the first hole? Now, if you see the hole now here is changed. The hole now is getting smaller. So the order here will be this one. This one will be number 1. Okay. So we'll move number 1 here. So this, now it is a new hole. Okay. So suppose it's the same order. Okay. So this is order number 1, 2, 3. This is the hole. So we put it first fit. Okay. We put it in this hole. Okay. The first free area that is enough for this process. So this is the idea of first fit. We keep on putting the first the process in the first free area. We find it, the first hole. We find it if it fits, yani if the size is enough. Suppose we have now, this is the hole is getting smaller and smaller. Okay, now this is the new order. Suppose we have process number 13. Okay, process number 13, for suppose it's little big. Okay, it's very big, huh? So it cannot fit here, it cannot fit here, it cannot fit here. So what shall we do? This process will be waiting. Okay, so this will stay waiting in queue, right? So this is waiting. Because we cannot, it does not fit to any place. Okay, so this is the idea of process allocation. This the first strategy, the first fit strategy. The second one we have here is the second strategy is best fit. Best fit, where we allocate to the smallest hole that is big enough. Where does it best fit? So we search all the holes. So we check this one and we put it in the first hole here. Okay, this is the hole is very big. Now we put it here. This is okay, but there's small free space, the hole is getting very smaller. So still there is a white area here, and we put it here. Okay, and we see, okay, this one is also big. So which one best fit? Okay, like, okay, so the one that is best fit, if you see, notice, is this one, because there is the least free space available after we put it here. So this one fits best here. Now we have free area, and the hole now is getting smaller here. If we get another one, process 12, okay, it might be here, but is there a better place for it? It can fit. We can put it here. Now, no, it cannot be here because now there's no enough area for it. So we move it to the second one. We put it here. Now, which one to select? Hole 1 or hole 3? We will select hole 3. Why? Because the free space area, the free white area here is less. So it best fit. Here, the white area is very large. The hole is large. We want the smallest possible hole where it can fit. Okay. And if we have process 13 here, okay, we can, this best fit for it. Process 13, very nice for it. Okay. So this is a best fit algorithm. This is a best fit algorithm. The last algorithm here we have is the worst fit algorithm. The worst fit. So we search for the size that is the hole that is very large comparing to the process. So we put it here. The hole is large, and in hole number 2, no, it's less. So hole number 1 is larger. Hole number 3 also it's less. So the largest hole will be available will be, we will put process, the first process here. This is worst fit. We go to the process 12. Okay, which one is worst fit? It seems this one is still large. This is the largest one. This is okay. This is, so we put it here. Okay, and this one does not fit anywhere. Okay, so we cannot put it. So it will be in the waiting. Right. So this is a worst fit. Right. We can make this little larger. Okay, or smaller, I don't know, whatever. So anyhow, this idea is we put in the worst fit. So this one, this is the worst place we can put it. Suppose it's very large like this. Okay. Okay. No. طيب. Anyhow, I will show you another example, maybe with numbers, because to be more precise. Right? Okay, the other example I will give you with numbers. Now, these are the like exam questions. Right? Okay, an example here, you are giving 5 memory partitions. Partitions, يعني 5 memory partitions, it means 5 holes. 5 holes. A hole of 100 and a 500, 200, 300, 600 in order. This is the order of the holes. So this is order number 1, 2, 3, okay, etc. And we want to use the strategies of first fit, best fit, and worst fit algorithms to place processes in these locations. Now, these are the theory. We are explaining to you the algorithm. But there is a programming for it, the programming side of it. So now I will give you the ideas and the programming. As far as I know, it should be somewhere in the, you can practice it in the lab, and maybe we can give it you in as a project, but I need to finalize this project thing with the coordinator, so it's taking from me a lot of time, but anyhow, soon we will decide on it. Right. uh, Anyhow, this is the processes here. We have the processes available are a process of 212 kb and 417 kb, etc., etc. So these are in now we want to check which algorithm make the most efficient use of memory. يعني how we can say it is using the most efficient use in memory. يعني it will have the least available, the least space in in memory. يعني we have less holes, let's say, or okay, this smallest hole size. Okay. طيب we'll see. uh, uh, the first one, I will order this. I designed this for you because it's easier for you. So we have the available holes in order. I put it here. This is in order. Okay. Yeah. This is 1, 2, 3, 4, 5. Okay. So we are ordering the free holes, and this is the available processes in order. So you can imagine that in first fit we find the first that fits the 212. We don't have exactly 212. We have a larger hole here. Okay, this is less hole, this is larger, this is larger. So, but in this algorithm, the first fit algorithm, we always put it in the first. So just we have an illustration. We should, you see here it does not fit. It does fit here. This is the first one we found that it fits, so we put it here directly. خلاص. So we go to the second process, 417, and again we check the first hole here, it does not fit. We go to the second hole here, it does not fit. The third hole here, it does not fit, the 200 hole. We go to the 300 hole, it does not fit. We go to 600 hole, it fits here. So we put it here. Okay. Now we go to the 112. 112, it does not fit here, and it does fit here. So this is the area where it fits. And the last one, we have the 426. Okay, we try to place it here in the 100 area. It does not fit. Here it does not fit. In the 200, it does not fit. In the 300, it does not fit. In this remaining also, it does not fit. So what this process will do, this process of size 426, it will wait. Okay, so this one will keep waiting. Okay, it will be waiting. Right? So this is the idea, what I'm explaining. So if you notice here, 212K is put in the 500 partition, this one. And then the 417 is put in the 600 partition, this one. And 112 is put in the remaining, this one. Okay. So the remaining is 500 minus 12, 212. This is 212, and the original size of this area was total 500. It was 500. So 500 minus 212 is remaining 288. So inside this we put the 288. Okay. So anyhow, this is the uh, the uh, first fit algorithm. And lastly, we have 426 is waiting. طيب. Now, suppose we want to check the best fit algorithm. In the best fit algorithm, best fit, we search all. Okay, we search all available holes, and we select the best fit. Okay, so we will check, is this is best fit for 212? No, this is large. This is the 212 is larger than the 100. For 500, okay, we can put it here, but is there a better place for 212 or not? So we go and check here. We have the 200. So we can put it here, but no, it doesn't fit. This is 200 and this is 212. It's larger. We can put it here. Yes, we can put it. We can put it here. Yes, we can put it. So which one to put? We can put it here. Okay, and we can put it here. We have options, and we can put it here. We have three places we can put 200 watt. So the best fit algorithm, we will check which one has the least hole after we put the mm. So we can put, if we put it here inside the hole, and this we put here, and we can put it here. So which one has the least hole? Okay, we can see that this is a big hole here, and here maybe even bigger hole, and this one is the smallest hole. So the best fit for 212 process is this area in memory. So we put it here. Okay, so this is the best fit algorithm. So we put the best fit. Okay, now we go to the second one, 41417. Okay, we check, can it fit here? No. Can we fit it here? Yes. Okay, is there any other place we can fit it here? Yes. We cannot put it in 200. This one is not, it's very small hole here, and we can put it with the 600. Now which one has the least remaining hole? We see here the hole is small and here is small, but which one is smaller, or the smallest hole after we put 400? This one. Okay, so better to put the 417 here in this area, not here. Okay, here this is a larger hole type, so we keep 417 here in this area. Then we take the next one, 112. Okay, 112, and in 112 we will search for the best fit. Here does not fit because 100 is less and we need 112. Here it cannot fit, it's also small. It can fit here, this area, and it can fit here. Which one is best? The one with the least hole. So this is the least hole. Here we have small hole, here we have very large hole, so we put it here. The last one here, 426, we try to put it in 100. No, small. Here the remaining hole also small, hole here also small, here also small. The best one fit is the 600, so we put it in the 600 area, and we have smaller holes here in these areas. So this is a best fit algorithm. So 200 200 212, we put it in the 300 partition. The 417 process, we put it inside the 500K partition. The 112K process, we put it inside the 200 partition. And the 426K process, we put it inside the 600 partition. If you notice, in the first fit, we could not put the 426 process. It's waiting. But in the best fit, we found a place for it. So this is better than this one. Okay, let's see the last algorithm, the last mechanism of memory allocation, which is the worst fit. Okay, in the worst fit, we will search for the largest hole. Okay, largest hole. So in 212, if we put it here, no place, we can put it here, and there is a hole. We can put it here, and there is a hole, and we can put it here, and there is a hole. So we keep it in the largest hole. So which hole is the largest? Is it this one, or this one, or this one? If you notice that this is the largest hole we can have. This is the largest hole. Okay, so we keep it inside the largest hole, right? So the 212, we put it in the one which they give us the largest hole, not the smallest hole, opposite to the uh, best fit. Right, 212, and we go to 417. 417, you cannot put it in the 100, you can put it in the 500 here. Can we put it here in this area? No, it, this is larger. You cannot put it here. You cannot put it here. You cannot put it here. Only one place we can put it. Okay. The 112 cannot fit here, cannot fit here. We can put it here, and we can put it here, and we can put it here. Which one with the largest uh, hole? This one, or this one, or this one? Okay, so we select the remaining uh, this one. This is the largest one here, so we keep it here. Right, this is the largest. Also, we have 100. We have the last one, 426. 426 does not fit here, does not fit here, does not fit here, does not fit here, does not fit here anywhere. So again, we have 246. It must wait. So if you notice here, the 212 is allocated, 417 process is allocated, 112 process is allocated, but unfortunately we could not allocate 426 the same as we did here in the first fit. So which algorithm is the best for us? The one we could allocate all the processes in memory successfully. So this is the best fit algorithm. The best fit algorithm in this example. In this example, maybe in some other examples it might not be. Okay. So you can calculate. You can calculate this. يعني how does it fit, or it fits or it does not fit. You can make it in calculations. Like, and if, for example, if you are writing a program, so, and this is the available holes. So we have h1 hole equals 100, h2 hole equal 500, h3 hole, okay, equal 200, and you have processes p1 memory equal to 212, and p2 equal to 417, and p3 equal to 112, and then you want to make the like a loop, a while loop. So you can create a while loop, okay, or a for loop, whatever. So you can write while, okay, we have still, and you can write a counter, okay, for the holes, okay, holes counter equal 1, and while we have still enough holes, hole counter is less than how many how many holes we have, 1 2 3 4 5 6, less than or equal 6. So we for the all the holes, and we can start comparing every hole. When we find it, we say if. So we can put it in an array, by the way, instead of variables. So you can say if um, okay, if the process we have p of, let's say, I, if the process size is less than or equal the whole size h of j, okay, then it fits. So you can think of these processes like an array. So you can create an array of h with 5 or 6 elements, okay, so equals, and you can put the values inside it, 200 and 500 and 200. So you can program this, and you continue putting the other numbers, and the process is the same. So the point I want to mention here is, if you would like to program these kind of things, you can put them inside arrays. So you have the array of the holes, and you have the array of the processes. We have 4 processes and 6 holes, okay, and the processes we have is 2 and 2, Okay, 417, etc. You can fill the numbers, and then you have a whole counter and a process counter. Okay, all start from one, and then you can make a comparison between them. You can make loops, for loop if you wish, for of I, for of j, instead of a whole counter I of j. Anyhow, you can play with it, but the point is, any algorithm you would like to use, you have to check the remaining uh, holes, and you can update the holes. So the holes might increase size, or the hole might decrease in size. Okay. These dynamic things, there can you can find in the internet many ways to program these best fit, first fit, or worst fit algorithms in C language. I'm simplifying here the things just for you. Anyhow, enough for today. Uh, in The most important thing for me now today in today's class is you have a better understanding of these three algorithms in theory. Also, this is a theory question, and inshallah ta'ala things are clear. If you have any questions, you can always write it down in the chat. I hope everyone is okay. Uh, then inshallah ta'ala we'll meet after Eid. So Eid Mubarak inshallah al-Jami', and happy Eid, enjoy your vacations, and keep inshallah ta'ala we'll see you next class after Eid. جزاكم الله خير. Thank you very much. السلام عليكم ورحمة الله وبركاته.